Okay, I am now talking to an empty classroom except for one very hard-working student who showed up here. That's there. Thank you for coming. At least I don't have to look silly talking in front of an empty room. That there. This is actually a fairly important class for the three of you who did not show up because this is the introduction to MATLAB. So we're completely shifting gears. I'm done with C, and I'm completely shifting gears to MATLAB. Right there. Now, as it turns out, I've already recorded pretty much everything I'm going to cover for a workshop that I did, and I'll post those links later. But everything I'm going to cover over the next few weeks is going to come out of a workshop that I did for the faculty at UNIKL MFI. They're in actually the chemical group there back in September. That there. So, but MATLAB is a program that is not intended to be a programming language, but it can be used as a programming language. That there. So, basically by the use of script files. That there. As the name indicates, right there, MATLAB stands for Matrix Laboratory. So, what it does better than anything else is matrix manipulation. Right there. And we look at most things from a matrix standpoint. This is the default desktop, and I'm going to, before I get started on this, let me talk a little bit about MATLAB right there versus Octave. These are two different programs. MATLAB is what is the granddaddy of numerical calculators for engineers and chemists and all kinds of other scientists. Right there's that there. It's put out by a company called MathWorks out of the U.S. That there, they've been around for quite some time. That there, and let me close this out here. And it looks like this right here, where I have my command window. I have my toolbar up here. I can have plots that I want to select a variable to plot right there. And it has some applications that there, for example, instrument control panel. I can add in various instruments right there. I don't have any installed on here right now. That they're Bluetooth serial. I have no instruments added to this right here. I can add function signal analysis, for example. Right there, a chirp filter. Right there, these are beyond the scope of this course. I have a PID tuner, which is for feedback control systems. That there, beyond the scope of this course. Curve fitting apps, right there. These are all that there. But the basic MATLAB is actually just the toolbar and the use of M files. There, we'll talk about M files. Oh, morning. It's Coom. That there. That there. I went ahead and started without you simply because I want to get the introduction done, and I figure you guys can watch the recording if you weren't here. But MATLAB is that there. MATLAB is very expensive. Yes. Very, very expensive. And we've only got one lab for MATLAB where I'm going to move the class next week, inshallah, up to the 6th floor to that lab out there. That is the only lab that we've got MATLAB installed. It's not on these computers here, right there. Now, for sake of this course, and for doing what you're doing, you don't need MATLAB right there. There's another program that's out there, and it's called Octave, and I just put a link to where you can download Octave. Octave is the shareware version of MATLAB. There's the open source version right there. So this is free software, C source code for copying that there. Now, of course, like anything else, this is version 4.03. I noticed this morning that 4.2 is out. I downloaded it. I haven't tried it yet. So, if you go to the website and download version 4.03, that's what I'll be using right there. So, but you can do all the labs that I'm going to assign, including the final project, with just Octave. You don't need MATLAB right there. That there. MATLAB is useful if you want to use the toolboxes and some of the other tools that are even more expensive than MATLAB.
Is there any difference between Octave and
Okay. All right. The question is there any difference? And the answer is none at this level. There is some when you get to some of the more advanced topics out there. The biggest issue is that MATLAB sells, for example, a toolbox for signal processing. So it's got FIR filters built into it. It's got IIR filters. It's got all those. Some of those are available through some libraries that you can find for Octave, but at there. So some of those, but those toolboxes are $3,000-4,000 USD a piece. I mean, if I look at, I don't know if I get, do I have internet in this room here? Oh, here's my internet. I knew I had an internet cable normally for this room. It just went away right there. But right there. I keep hitting one of the, actually I want this. That one there. Yeah, this is the index right there. Right there. Well, okay. Standard MATLAB for an individual to buy it is $2,650. So you're talking about 11,000 ringgits to buy a copy. Educational version is 650 USD. So again, you multiply it times 4.4. And you're sitting 4 is 2,500. You're close to 3,000 ringgits right there. So then, if you also look at, say, for example, digital control signal processing, right there. Signal processing, the toolbox. And I guess if you have to ask the price, you can't afford it. That there. Product pricing. The 1,200 for the signal processing toolbox, that's USD. If you look at it for education, it's 250. But so you're talking about 1,100 ringgits again. Still, you're still talking right there. So MATLAB is expensive. Let's just leave it go at that right there. And the student version, actually, which you can't get the student version here, because it's only for right there, learn more right there. I think it's only for within the US, but the student version is actually much cheaper. Let's see, buy now. Yeah. Malaysia is not listed as one of the countries you can buy it from. And the problem is in order to be listed in one of these countries, you have to be part of a group that promises absolutely no use of pirate software. And unfortunately, I hate to say it, Malaysia doesn't have a strong reputation in terms of use the pirate software. You notice China is also not on that list, nor is Vietnam or Thailand. You know, pretty much all of Asia is off that list. If there's, I recall, oh, up there. It didn't. Select your country. It's Australia, India, New Zealand. I'm not sure what these might be. South Korea, Japan, and I'm not sure what the third one is. I'm sure it's not China. Right there. Europe, pretty much everything in Europe is covered. But if I hit United Kingdom, for example, I'm willing to bet the price changes. Right there. Yeah, it didn't change too much. Yeah, because MATLAB and Simulink, and you can add in some of the control systems. The signal processing toolbox is part of that there. So there's student prices that are actually pretty good, but as you notice, you can't get the student price here. So my recommendation is, if you want to use this, you stick to Octave right there. So, and again, Octave will read the same M files. It can use the same commands. It plots the same type of graphs. The user interface is very similar right there. So, and I'll probably just go ahead and use Octave for my demos just to make life easy for you. So, all right, going back to my slides, which we can't forget my slides right there. And again, the reason for moving upstairs is that it does have MATLAB installed. I have not asked them to put Octave in this lab. I think I probably should, but we could just use Octave for this class in the future. Right there. We have a command window where we can do commands one at a time. We have the directory right there for opening M files and saving M files right there, our current directory. And then we have our command history. Now, we can customize this command window however we want. Now, again, going back to our discussion on Octave, it's a very similar type window. Here's our command history. This is our workspace. Right now, I don't have anything on the workspace right there. And I could just type in some numbers. X is... I just want to use the same one. X is 0 to and 8 right there. And why is my keyboard not working? Oh, there it is. Okay. X is equal to, we start at 0. We go 0.2 units apart from each other. And we go to 8 right there. And we put a semicolon at the end. Now the semicolon at the end, what it just does is suppresses me from that there. I'm just going to leave the semicolon off, and you'll notice that it creates 41 columns going from 0 to 8, going up 0.2 each time right there. I can create another array. Y is equal to sine X right there. And that creates another array, and I can just type Y and enter, and it shows me what the contents of the array is. And that's the sine of X for all 41 values right there. Now I can plot these very simple by just doing plot X comma Y right there. And hopefully it comes up with a plot right there. And don't tell me that my MATLAB is broken. Or my Octave is broken. It worked back in September when I ran this workshop. So, well, it may not be working with it. Yeah, I did the recording. Well, you know what? Let's just run the MATLAB. The two windows are, the two commands are the same. It's just for whatever reason that hung up. And it could be because I downloaded version 4.2, even though I haven't installed. So X is equal to bracket 0, colon, 0.2, colon, 8. Close that right there. Y is equal to sine X right there. plot x comma y. Right there, and we have a nice neat plot very quickly. So again, you can see the beauty of MATLAB if you want to do things fast and dirty. It's much quicker than a calculator. And that's what I actually use MATLAB for more than anything else, is a high-power calculator. Right there. And that's what should have happened in Octave. And for sake of argument, I'm just going to try Octave again just to see. Okay. My command history, so x is equal to 0, 0 colon 0.2, and I can see 0.1, 8, y is equal to, I can use this keyboard sign, x, plot, x comma y. And my plotting is not working. Okay. All right. The answer to your question is they're supposed to work the same. And they normally do. It's just, like I said, I was playing around with the new version. I need to probably uninstall the old version and reinstall the new one cleanly right there. So, all right. For today, I'm going to stick with MATLAB, just simply because I broke Octave right there. So going back to my slides, this is the command window. Right there. It retains your previous keystrokes. You can use the up arrow to scroll back there through the commands. Press the key once to see the previous entry and so on. Right there. All that says is that I go back to MATLAB, I come over here, and if I go that there. So now I can say I want to plot 3 times, or I want y to be equal to 3 times that there, and then I plot x, y, and now notice that my graph has changed. It's now, I multiply the frequency by 3 right there. So, and you can change that around however you want right there, and I can go here and I could say 0.5 times. Let me put the semicolon on that there. I'm going to say z is equal to, actually let's just cheat, z is equal to cosine. And it will not let me do that, so I have to do a plot. I cannot plot. I can plot more than 2 on the same graph. It's just right there. It's just that the simple plot command doesn't let me do it. Okay. Right there. So, but again, notice that I can use the up and down arrows to break up previous commands right there. So, and then the backspace and the delete. And then enter just to execute. This just shows some examples right there. And again, all it is 8 divided by 10. It just tells me the answer right there. So, and I can say k is equal to 8 divided by 10 right there. It just comes back and assigns k. Now, what we're seeing over here in the workspace is that I've got a value called k right there, and it's got a value of 0.8 right there. That was the last calculation. I also have one that says answer, which is the result of the last calculation. X is an array. I can double click on it right here, and it brings it up as a spreadsheet, all the values of X right there. Y is an array right there, and again I can bring it up in a spreadsheet. It looks like this right here. Right there. So it's fairly straightforward right there. And I can enter my values into the array directly right there. So that there. So in other words, I could set up a new variable called k, or let's see, W, X, Y, W, and I set up as an array, which I'm not going to go through that, but I can set up, you know, any type of, in the workspace, I believe I can just say new variable right here, K, or W, and then I can double click on this right here, and I can just put in what W wants to be, right here. And notice that it fills it out to make it into a full array. So now I created, W is now a 3x3 array, and if I just type W here, you'll see that it shows up as a 3x3 array. So it's fairly easy to create matrix variables, right, with that there. You just go to the workspace, right click, new, give it the new variable, and then just double click on the little grid, and you just fill in the matrix however you want it to fill. So it's a very easy toolbox for dealing with matrices. So again, this is an example session. If I had MATLAB on these computers, I'd tell you to go through and do these, but they're pretty trivial out there. And these will work in Octave. It's just the plot seems to have a problem with Octave right now. We've got some of the same things we do with a programming language. If I want to take A to the B, we just use the up caret. That there, I don't know, what do you call that? We call it the caret symbol, that C-A-R-O-T, something like that, caret. Maybe only one R. Multiplication, right divide, left divide. Right there, right and left of division are a little different. When we deal with matrices, we can talk a little bit about that before. Left division right there. This simply, it's actually the inversion right there, is what that there. Addition and subtraction right there. Now, these can be either vectors, they can be matrices, or they can be single variables. You know, that's the beauty of MATLAB, is that it handles all of those equally right there. You know, again, the same order of precedence right there, parentheses, starting with the innermost pair, then explanation, then multiplication, division, and then finally addition, subtraction right there. Same order as C or any other language right there. Again, they're saying that, like, for example, 8 plus 3 times 5, it's going to be the 3 times 5 first. So it's not going to be 11 times 5, which would be, unless we put parentheses on it, which is shown right here, right there. Here we do the 4, and there's missing a symbol. I think it's the plus right there, minus right there. Right there. But again, you can play with all kinds of games with these but they're the same. You know, I'm not going to go through all these in great detail. The assignment operator works the same as programming languages. X is equal to 3 assigns the value of 3 to the variable X. So it's unlike programming with like a regular calculator. We have whatever variables we put in our workspace right there. You can type that right there. This assigns the value of 3 plus 2 to 5x. Again, it's like a programming language. So, for example, x is equal to 5 right there. Y is equal to x, or x is equal to x plus 2 right there. And that just changes the value of x to 7 right there, just like it does in C or BASIC or any other programming language right there. Oh. And we got to go all the way back right there. So if there in algebra we can write x plus 2. So in MATLAB you cannot right there. You know, the only thing that can be to the left of the equal sign is a variable name right there. And if you don't put a variable name down, For example, you know, if I just put down x plus 20, that's going to give me the answer 27, but x remains 7 in this case right there. But answer changes to 27. Answer is always the result of that there. Plus 5, that there. And that's just simply going to write that. You know, I can't, you know, that doesn't do anything. But I can say answer plus 5. That gives me 10 right there. And the value of answer changes. That's always the result of the last result right there. Right there. MATLAB must be a single variable. Yeah, that's it. The right side must be a computable variable, something that you can compute. Right there. And this talks about pages here. I'll post the book on the that I'm using, and I'll talk about the book in a second. These are some commands right there that you can use right there. And CLC just clears that window right there. Clears all the variables from the workspace right there. If I had x is equal to 7, y is equal to k, I can do it y is equal to, I can't say k, I'll say 8. And I can say clear y. That clears the y out of the memory, but not the x right there. Right there. And x just determines whether or not a variable. Quit does exactly what it's supposed to do, quit. So if I go into MATLAB and I type the word quit, it just shuts off. Right. Right. Continue. Who lists that there, and whose lists the sizes that there, and in the case of they have imaginary parts. Colon generates an array having regularly spaced. Comma separates elements of array. Semicolon suppresses screen printing right there, and dot 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 continues along. You know, these are just simple that they're. So in other words, if I go back to here, you know, let me just put in my first one, x is equal to, and I could say 0:8, for example, right there. This will not work right there. Well, actually it does. It just gives it that there. If you leave that middle value there, it defaults to 1 right there. What I had before was I did 0.02 colon. So the format of this line is my starting value, 0, the distance in between each of them, and my ending value right there. So if I put that in, that generates 401 values right there. And why did I have so many? Because I put 0.02 instead of 0.2. Before I had 0.2, so it only gave me 41 values. But again, I don't care how many points, so I just put the semicolon that suppresses the printing right there. So I don't get all this garbage right there. So I can CLC. I want to keep writing CLS because CLS was the old basic command for clear screen. CLC is the Linux command or Unix command for clear console. That's where, yeah, everyone wonders where that CLC comes from. It comes from text-based. And you got to remember that MATLAB was originally written in Unix for Unix systems, right there. So, and Octave is still written on in, you know, I think they use Fedora to write. It might be Red Hat, but Octave has been around for a long, long time, long before MATLAB. MATLAB actually took Octave and made it commercial. And did for Windows. Octave has been around for Unix systems for many years. So Octave is the older of the two products. At least that's my understanding. I won't go on. Don't put me on the evening news quoting me, but as I understood the history of it, Octave has been around longer than there. It's just like PSpice, which is the basis of electronic workbench, or what do you guys use for your electronic circuit or circuit analysis program? What's that? You don't use PSpice, but you use something else that there. It used to be called electronic workbench. That there, where you draw the op amps and the resistors that there. Your first circuits course, what did you use for doing your circuit simulation? What? Principle? I haven't heard that one. That there.
Multi-sim.
What's that?
Multi-sim.
Multi-sim, yeah. Yeah, multi-sim uses the SPICE engine for doing the circuit analysis. Yeah, because multi-sim used to be the electronic workbench. Right there. Right there. It's National Instruments right there. But it looks like this right here, right? It looks just like that, right? Yeah. Yeah, multi-sim used to be, it's now owned by National Instruments right there. So multi-sim basic edition right there. But that package uses a program called SPICE behind it to do the actual circuit analysis. SPICE is an old open source project that was designed back at, I want to say Caltech, but it might have been one of the other California universities designed it, that there. And you used to have to type in netlist by hand, that there. In other words, you would say that you draw your circuit, you number your nodes 0 through 20 or whatever. Node 0 was always ground. And then you would say between node 1 and 2 I have a 10 ohm resistor. Between node 4 and 5 I have a 0.5 farad capacitor. Between here and here I've got a transistor of a certain type right there. And it's all text entry right there. And that was SPICE. And then from SPICE later it became a program called PSpice, which is what I still use. And if you look at PSpice, right there, that's also that's now owned by Cadence right there. And I actually still use PSpice in my courses because there's a version of PSpice called PSpice Lite, which is free right there, which is, and when you look at PSpice Lite right there, it includes OrCAD's capture, PSpice, analog digital, that there. It includes the demo versions, and the main thing is that, as I recall, the demo versions allows you to only simulate circuits of a certain size, right there. And of course, PSpice capture allows you to draw schematics, capture them, that there. And then there's also the PCB editor that allows you to draw PCBs from. It takes the net list from OrCAD and maps it over to there. I've been using OrCAD for years in industry, so I'm more in tune with OrCAD than I am that there. A little history is multi-sim, which used to be electronic workbench, was originally sold by a Canadian company as an academic only type package. It was not designed for real work. So industry used OrCAD, which later Cadence bought right there. And then electronic workbench was then bought by National Instruments that also does the I just drew a total blank, but they do the add-on data acquisition boards for lab instruments right there. You know, what is National Instruments famous for? they actually have a shop products, because electronic, see, again, they sell a lot of instruments, software. LabVIEW is what they're most well known for, is LabVIEW. And LabVIEW actually ties into various development boards to do a full range of things in the lab versus having a lot of lab equipment right there. And again, these are add-on modules for up there. My old campus, we had LabVIEW, and we had a LabVIEW lab with LabVIEW workbench, and students could do their labs on up there. And instead of using electronic workbench, it would actually show the results using the actual hardware right there. So, but National Instruments now owns electronic workbench, which they now call Multisim, right there. And OrCAD is now owned by Cadence, right there. But again, both of those products started off just like MATLAB did in the universities, as the university gets this large grant to develop a software package to do circuit analysis, right there, or to do numerical analysis, right there on matrix. Right there. So MATLAB was, Octave was developed by university. I'm not sure which one. It's gone into the open source where people share it around, and it's always being updated by volunteers. There. So, and then MATLAB has taken that product and it's commercialized it and has added on a really nice user interface, developed a lot of toolbars, and that's their value added right there. Most universities outside the U.S. use Octave. MATLAB is right there. All right, getting back to the discussion right there. Oh, I was going to show the who's and who's. I'll skip through that right there. Answer, I already mentioned what the answer is. I and J are both used for imaginary numbers right there. Originally, it only had the I, but because electrical engineers were using it, and electrical and electronics people tend to use I for imaginary, I for current. We tend to use J for the complex part of a complex number. They use I and J. The mathematicians in the world tend to still use I as for imaginary right there. Probably everybody in the ICL department other than Aswana probably knows complex numbers is real plus J in the imaginary part. Aswana would think of it in terms of real plus I times the imaginary part there. So, I never use NaN, indicates undefined numerical result. That just simply means, you can't find it. That would be like the value of something divided by 0. Right there is an undefined answer. EPS, again, I've never used it, but we specify the accuracy of floating point precision. That kind of gets you out of the idea if you're talking about calculating current and voltage values and resistor values and carrying 12 decimal places. I think you would probably be laughed out of the lab if you said that the current was 3.297812613.789 amps, right? You would say 3.2 amps right there. You would round it off to 1 or 2 decimal points at the most, because that's all your equipment's good for. Right there. I mean, your accuracy is no better than the equipment you're using to measure. Right there. And if you're building analog circuits, and you're using resistors, for example, resistors are typically plus or minus 5%, 10%, or 20%. Right there. Most resistor values are far from accurate. Right there. So, and you can use the number pi. Complex. You can put the I or the J right afterwards, and it works. It's fine right there. You don't have to use the times right there. Be very careful if you do the multiplication, because again, they're showing right here y is equal to And again, oh, that's right, with the screen resolution, that messes up my pen, if I recall. But if you look at this right here, y is equal to 7 divided by 2, that's not the same, because, right there, because this will do this first, so that's 3.5 times I, so that's 3.5i. This is minus 3.5i because the I is underneath. Right there. Remember, 1 over I is negative I. Right there. Formats, you can have format short, 4 decimal points, long, 16 decimal points, short E, which means that's going to be an exponential right there. They don't have engineering notation. And for those of you who are not familiar with engineering notation, that's the same thing as scientific notation, only you only have multiples of 3. And that makes it easy because you have 2.5 e to the negative 3, so that's 2.5 milliamps. So, or it would be 25.3 e to the minus 3, which would be 25 milliamps, instead of 2.5 e to the minus 2. Because the minus 2 doesn't translate immediately to an engineering shorthand. Milli, micro, nano, right there. So, and the other way, kilo, mega, giga, in that direction right there. So it doesn't have engineering notation right there. I don't know, they probably don't even teach engineering notation anymore. A lot of the old HP calculators had engineering notation in there, and I loved it right there because it enabled me to shut my brain off a little bit right there. I didn't have to think, what is 2.5 e to the negative 2? It would show up as 25.2 e to the negative 3. So as soon as I see the negative 3, I put a little m there. Whether it's negative 1 or negative 2, negative 4, you have to start thinking. Or if it's 4, 2, or whatever, right there. So, the engineering notation I always liked, too, right there. Again, this just shows what I've already talked about right there. Now, I don't know, it shows the red dot in the right place, but when I draw it, puts it there. So there's something definitely wrong with the that there. Yeah, because you see the dot is in the right place, but the line is drawn completely elsewhere. That looks like a real error in the operating system or something out there. But it only occurs when I've got 2 screens hooked up of different resolutions. Out there. So again, this is similar to the example I gave originally, right there. So I don't need to go through that there. So again, array index. I can look at individual elements in my array. So I can say x20, for example, and that just tells me the 20th value in the array right there. And the other one that they were going to say was the length right there. And that's 401 elements in the array right there. So now that length is useful if you're writing M files and you're using for loops right there. So there is a very neat little function called roots. You probably wish you had this in one of your math courses, right? Where I could put in a function right there, and this is x cubed minus 7. I don't have anything to write, but I need to bring a pen where I can write these notes. Oh, I got paper, but I didn't bring a pen. That's right. Someone remember 1, negative 740, negative 34. Well, it doesn't really matter right there. Let's just say x is equal to, and I want to see something right here. Okay. Use commas. And I'm going to say x to the 5th minus 2x to the 4th, 3x cubed, 1x squared minus 5x plus 7 right there. And I forgot to put the equal sign right there. So I've just now declared a fifth order polynomial. X is x to the fifth. Let's see. X squared, x cubed, x to the fourth, x to the fifth minus 2x plus 3, or minus 2x to the fourth plus 3x to the third plus x squared minus x plus 7. Right there is what that there. And I can just say roots x right there. And that gives me my 6 roots right there, or 5 roots, excuse me. With the fifth order polynomial, I've got 5 roots right there. If I have any polynomial got there of an order greater than 1, that's there, it's going to have an equal number of roots as the order of the polynomial. Now, some of the roots may be real. In this particular case, I've got one real root at minus 1.2783 right there. And I've got 2 pairs, they're conjugate pairs, at 0.713 plus or minus 1.56J, and then another pair at 1 plus 0.90, plus minus that there. So those are my roots. So I could take any polynomial that is factorable, and they're all factorable. It's just whether or not you have real or imaginary roots, and just simply put it in there. So if I have x squared plus 3x, let's say x is equal to x squared 3 and 2 right there, and roots x, those 2 should be real right there. Right there. And so there's my roots, and that's the polynomial, 1 plus 2 times x is equal to 1 plus 2 times parentheses x plus 2 times x plus 1 plus 1. That's that polynomial. It's the only one I can remember off the top of my head here. But those roots when x is equal to -2 will give you a factor of that there. And again, I can also simply say x is equal to, and I'm going to say -5 colon 0.01 colon 5 right there. Yeah, I don't know why now I know why I'm doing that. Right there. But there, y is equal to x squared plus, what did I say that was? 2x. Let's see. Plus 3 times x plus 2. Right there. Right there. Oh. This does not, like, you got to put a period there in order to calculate that there. I forgot, when you're dealing with matrices like this, and you want to do the exponential, unless you're raising one matrix to another one, or you're just dealing strictly with scalars, but you have to put the dot after the variable name before the exponential and tell it to do each one individually. Right there, and I plot x, y, right there, and you'll note that it crosses. And this one's kind of an interesting one because that did I put that in right? Right there. X squared that looks right, right? I should have two roots and it looks like it's showing a single root. And that doesn't look right. All right. Right there. What am I doing wrong here? That there. Yeah. Talked almost an hour. Maybe my brain is starting to shut off there. X plus 2, X plus 1, right? That's X squared plus 2X plus X plus 2, right? So that's X squared plus 3X plus 2, right? You know, so that part's easy. That there, we should do that there. And my formula right there is y is equal to x squared plus 3 times x plus 2. That looks right. Right there, and right there. But when I plot it, it sure looks like, because this should go down further right here. It should hit 0 at here and here, and will be below 0. It might be right there. Let me just change this here. Let's change something here. Let's just take it to 0 right there. Oh, I need to recalculate y right there. And let me go from just 4. Just go to 3 actually. Yeah, now you can see our roots are at the right place right there. The problem is the graph wasn't fine enough in that area up there. So actually it would probably, there's a way to turn the grid on too right there, which we'll get into later right there. So again, this just basically right there. The commonly used functions right there, and that's a partial list. You know, a keynote is that whenever you're dealing with sines and cosines or anything that deals with angular measurement, it's got to be in radian, just like C. Right there. So e to the x is exponential, square root, log 10 is log 10, sine, cosine, arctangents are that there. So now when you type something, it's going to look to first, it's going to look to see whether or not it's one of its own commands. Then it's going to look for an M file. We haven't talked about how we build M files yet. You know, that there. We'll be talking about that next week. Right there. So it looks for the current directory for M file. Then it goes through what's called its search path. Right there. That gets relatively complicated, but it's looking for something that does that particular thing right there. Problem 1, it goes through it right there. This is getting into how we add paths to that there. The easiest way to add paths right there is that we simply go over here to the current folder right here, and we look for, this is right there, but we can also use what they call the set path right there, and this is everything that's in the current path. And you notice that I have a lot because I have a lot of toolboxes, but I can hit add folder and I can look for a particular folder, users, and usually I don't have a folder here called MATLAB, but usually I would have a folder called MATLAB. Well, we'll just create one here. Right there. And then now that's been added. Oh, there is one already, documents.matlab. I didn't look at there. So again, save, and now that anything that I've got saved in that directory would look for right there. So right there, but they've got this little set path variable right there, and you know, you can, on the other hand, you can come over here and you could go CD right there, and notice that it changes this to the root directory, CD users, CD standard right there, CD document right there, CD MATLAB right there. Then it just shows me what I've got in that particular directory that they're in. And again, I've got some M files in here, for example, right there. If I double click on that, this is just simply a tree called, I don't know what that is right there. Cool. Robot test, for example. This is a function I wrote for testing some robot arms we've got that we talked to right there. I've got a function here called, here's one where I can do a plot right there, and why I've got two X's up there, that doesn't make sense up there, but right there. But I can, at this point, I can run this right here, and it shows my, so it runs this as if it's a program right there. It's an M file right there. Again, I said we'll talk about creating M files later right there. So, and again, we can, up there, and you can see these things where remove path, directory name, pwd, what, these are all Linux commands right there. Graphics window showing plot, we've already done that there. So again, we can put labels on here, X label X, Y label Y right there. We can add labels right there. I don't use the graphical input to get points for a plot right there. It's just on the grid right there. So in other words, I can go back to here. Grid. You can tell it's been a little bit while there. Plot. Right there, X label. And right there. Grid. Places grid lines on a plot. Actually, I think you put that, oh, you put it afterwards. That's what I did wrong here. This word grid comes after the right there. So that just shows the grid lines right there. Is all it does up there. And again, you can do X label. there. And you notice it just puts the X and the Y. So, and you can play with colors, you can play with line types, all that stuff up there. So, I'm going to kind of wind it down here a little bit. I had not gone through all the slides. I think actually I'm only on slide. Oh, what slide am I on right here? I haven't even got to that slide. Resume slideshow. I'm on slide 23. And there's 67, so I'm only about halfway through, which most of the rest of these are fairly up there. I have a book that I'll be posting right there called MATLAB for Engineers, which is a good title. Right there, it's by Palm, and I'll be posting that there. That's where these slides came from, so right there. He's a mechanical engineer, so I picked the book because originally these slides I was using for my workshop, which was all mechanical engineers, right there. So a lot of the problems out of the chapter are mechanical. The next thing I'm going to be talking about is doing a system of simultaneous equations, which follows more under the electrical. We tend to do that more than mechanical systems. So. All right, that's my normal hour lecture, so...